Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM radio. It is another Friday evening, and this one is February the 9th, 2018, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal time would put it at 2 o'clock in the morning, Saturday morning, February the 10th, 2018. So right now, for the next hour, we are live. My name is Marty Kunz with my co-host,
John Foote.
Welcome, John. Glad to have you again this week.
Filling in for Sky Guide Nick.
Yep, Nick's out with a little bit of dental work, so it's something that quieted Nick down. Hey, Nick, how you doing? Nick's in chat. I'm in chat. We got Optronics, Glenn, Twist Edge in the Quiet Wood, and Selby so far in our chat room. Come on over. Go to the homepage where it says Radio Chat. Click on that. You'll get to where it says login. Just type in the name, and then don't do anything with the password. Leave that blank, and then just hit the word login, and you'll be in our chat where we're going to put some links to topics that we'll be talking about. Then those links will go into our homepage and Facebook page, and you could actually look in those links when you listen to us on the repeat, like some of you do. Don't always get to us on the live portion because it is off hours for a lot of people. So we repeat this program every 4 hours for the next 24 hours with other programs too. So tune into all of those. Go ahead.
How about a brief little apology?
A brief apology?
To Astronomy Cast for cutting them a little short here.
Oh,
so
yeah,
that's
correct. Yeah, that's
correct.
correct.
Asked for a little apology there. Sincerely, of all the ones to cut short for a second.
Yeah, sorry about that.
Astronomy Cast isn't on the top list. Sorry about that one.
But yep, some things get a little twisted around sometimes, and we set the radio station going, and then something glitches and sets us off time a little bit. So we have to catch up and change and stuff like that. So at least we didn't interrupt the Super Bowl or anything like that, What was that? People, no, it was just the opposite. Was it people watching a movie and the Super Bowl would interrupt it, or people watching the Super Bowl and then they got interrupted by a movie or something like that?
Yeah, didn't they finish that to go with a little movie? Yeah, that was one of the first Super Bowl.
That was Super Bowl.
Not Gone with the Wind. Von Trapp family. Why am I thinking the Von Trapp family?
I don't. You're thinking of Hills Are Alive with the Sound of Music,
yeah,
or was it Heidi?
I think that's it. One of them, Heidi, was it?
I don't remember. Yeah. Well, anyways, the Super Bowl is like the last final game of American football. Kind of a big game to American football fans. And there's times when something has been preempted, either a movie or the game, and they tried to overlap, or they tried not to overlap, but it just went that way anyways. Oh well, anyways, we're going at it. Let's still go back a little bit to the SpaceX. We covered it a little bit Wednesday, but not everybody.
Beautiful launch. No, fun, yep. Beautiful launch, wasn't it?
It was. It was the big heavy rocket. What do they call it? The Delta.
Big heavy rocket. What I looked at.
Yeah, it was the heavy rocket. What's the heavy rocket called? Is it Delta? Here I am. Oh, Falcon, sorry. Delta's a different one. Yes, Falcon Heavy, what it's called. SpaceX from Elon Musk launched their biggest rocket. So two boosters and sort of a center booster, but they call it the core. All that to lift up the capsule at the top of the center one. First time ever launching the system, 27 engines. Total or per rocket? I can't remember.
Wow. It was total.
Total? Okay.
It's the way they stacked them.
9 engines per each section.
Yeah.
So 3 sections, 27 engines. Anything could go wrong. In fact, being a new system, this was kind of a test flight. And yeah, this is when you shake the bugs out, but it's
surprising. This thing, it was really surprising, yeah.
Yeah, the bugs could get you too. So they said, yeah, about 50-50, 60-40 chance of failure, but it launched. It launched just fine. This is the kind where each of the sections the lower sections would actually return to Earth before burning up. So launched with all 3 sections, went up, then the 2 side boosters flew away. They actually traveled a little bit, turned around, fired their engines, reversed course back to the launch pad, and then landed back near the launch pad.
Did you see the launch pad return?
I did see them, yes. So both
did you get to hear the kaboom?
No, I didn't see that video.
They both I'm looking for it. I had the video. It's a personal video of somebody, so I don't really want to post somebody's personal video.
Mm-hmm.
But they were pretty close, and it was beautiful.
If they put it out there on the internet, then
they come down fast. I'm like, whoa.
Yeah. And
then they almost come to a stop in the air.
Mm-hmm. So obviously they have some like landing gear that comes out like a tripod, like a telescope tripod. You can follow that down on the camera, but this is the first time I've seen it from the view from the ground and watching them come out of the sky. They come down fast. Yeah, they did. Yep.
And then they ignite, and then after they've been ignited and they're coming down, then you get to hear the sonic booms coming through.
Mm-hmm.
And they've landed, and you still hear all the sonic boom sounds, and then you can hear them shutting off.
Mm-hmm. It's pretty cool. Now the third middle section went up higher, and then it separated and set off the second stage, and then it was also coasted for a little while, turned around, fired its engine, brought it back to Earth. They had a little glitch though. I've heard that it was an ignition propellant. Being liquid-fueled engines, in order to turn them on, you actually have to
pre-ignite.
Kind of like a lighter. I call it a Bic lighter type of system, or well, that's where they launch them in the beginning. They either get a bunch of sparks. It might be like a bunch of sparklers type of thing that creates a lot of sparks. It lights the fuel coming out of the engines. Then it goes up. Well, in order to fire the engine in space, a couple ways you got to do that. You either have to have another ignition system like that, or you have to keep them slightly burning. You ever seen the old World War II flamethrowers?
Yeah,
and some of the old movies. Yeah, they when they're not shooting the big flame out there, they've got a little bit of
remain lit.
Yep, a little bit of flame on the tip, kind of a pilot light.
But this just looked like the future. It looked like I was in the future watching these things land. I knew I was in the future. It wasn't 1969. It's okay. I've seen 1969. This I knew. This is what the future looks like.
Yep.
When those two things they come back and they land it. Man, that was the future. We're living in the future.
So I guess the center one, that igniter flame didn't stay on, or it ran out of fuel or something like that.
It's all right. It wasn't important.
No, they lost it.
The rocket, they thought they'd lose the whole thing.
Yep.
And it wouldn't have been the end if they lost it, because it's not designed to lift people. If there's people going to be on these, you have to put double systems on double systems. Mm-hmm. These were the minimalist amount of systems, no backups of backups. It's just going to light and go.
This is also...
That's why a lot of these, they go off and they blow up, and it's okay. They don't have the backups to support an onboard failure. Because it's cheaper, and it's always a working out the kinks, getting the bugs out of the way. So if you lose one, it's not the end.
Yep.
Because you're going to find out what part let go, and you'll improve it next time. But if you put people on them, you always have to have backups of backups, and that's why the people rockets are so extra heavy. Because they basically are almost 4 rocket systems put in one. Mm-hmm. These are just the minimalist, one whole system. Go.
Yep.
And put that car in space.
This is also not the final version. I think they're up to like version 5 or 6, and these were like version 3. So they just basically use the earlier design model, and because they knew this was basically a test flight, and they just wanted to make sure the system looked like it was working, that they were doing the right things, and they got all the potential mistakes that they could see out of the system. So they figured out one little bug, but overall, not enough to kill the mission. It's actually quite successful. It lost the center section, which is actually a little different. It's actually more heavy duty than the 2 outside boosters, because the center section has to be able to hold the 2 side boosters onto it. So it's built a little heavier duty. But Elon Musk also said that the 2 side boosters had some more expensive parts on them. So when it really came down to it, the 2 side boosters were more valuable to recover.
Now, that's the money.
Than the center one, yeah, money-wise. So the 2 side boosters could be used again, except I think they're going to upgrade them anyways to more advanced systems. Payload was just a test payload. There's controversy.
Well, it could have been just a block of cement.
Exactly.
That's all he was allowed to put up there was a block of cement.
Mm-hmm.
Actually, it wasn't.
Yeah.
It gave him permission to put a car in.
Didn't want to risk an actual satellite. That's numbers on this. An actual satellite is anywhere between $50 and $400 million. So he didn't want to risk an actual satellite on a test flight that might not get off the ground and might explode and crash right away or anything like that. So they put in, since he happens to own an electric car company, he put an electric car in it, one of his, called a Tesla Roadster. And they put a mannequin in the seat in an actual SpaceX designed spacesuit. So pretty fancy. It was a convertible, pretty fancy looking red car, electric car with the guy driving it. Looked pretty good. A little bit of publicity there, but that's okay. It's dead weight. He's the cost of the car was, what they say, $58,000.
Unlike a satellite, this wasn't exactly put in a specific orbit. It was like, see if we can get it into there.
Yeah.
And it was actually a little bit better, so it's a little bit further out.
So it was a test flight. It was kind of like a company logo, that little advertising that they put up. And that was a controversy too. Why didn't they just do this? Why didn't they put a real satellite? Blah, 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 blah. Real science.
Extra work. Yeah, it's extra work to put a satellite up.
Extra work and extra money, 10 times.
And they would have needed the insurance. They would have had to put extra systems on the rocket. They would have been heavy. This was as minimalist as you can get and go.
I'm sorry, 100 times more expensive to put some kind of satellite in there. Yep. So didn't do it. So they put something for fun. Things actually they let it was a third. I think it did have a third stage. The 2 main stages for the main rocket. One final third stage. They launched it, aimed it in the general direction of Mars, fired the engines, and let them rip until they ran out of fuel. So things actually going to pass by Mars, not real close, but pass by Mars and continue on past Mars and get into the asteroid belt region. And then it's going to naturally just gravity, because there's no more fuel, no more rockets. It's just going to basically arc back and go back towards the sun and go around the sun. So it's actually in an orbit around the sun, a very elliptical orbit, kind of like a periodic comet type of orbit. It's going to go around asteroid belt, kind of far. I think he said 30-year or 60-year orbit. I can't remember which one. Something like that. So, but basically it's in a solar orbit, an elliptical orbit, and it'll just keep going and going.
Oh, I'm sure in 10,000 years they'll bring what's left of it back.
Well,
put it on Mars. They'll take it to Mars.
If we can't build a good rocket system,
it'll be in a museum within a future history.
Within 1,000 years, yeah. Then maybe somebody will snag it and actually put it on Mars.
It'll be in a museum, yeah. Mm-hmm. It'll be. They'll take it there. This was Elon Musk, who one of the first people.
I saw a post that it said the mission cost $90 million, which is relatively cheap. The shuttle mission is about $500 million to launch something up. This is like $90 million. So relatively, that's pretty inexpensive. But they're complaining.
$75 million an astronaut even?
No, I don't remember. They just gave it the general cost of a shuttle launch.
What were the Russians charging to launch astronauts?
What was the what?
Russians were charging almost that much to launch an astronaut.
Oh, I thought it was an astronaut.
25 million?
25 million. That's right, because some celebrities, that fairly rich celebrities, wanted to do that. And was it going to be 20 million or 200 million? One of the two. It might have been 200 million. That sounds like it, more like it. But I don't know. What else are you going to say? Oh, yeah, so the complaint was, the guy launched a car, $90 million to launch a car into space for fun. It's like, people just don't get it. This is testing a new rocket system to bring equipment and science stuff into space and eventually people. So it's basically like building a new truck, more efficient, less cost, and it's going to move stuff around the Earth where it's going to be useful. So, no, this was a test mission. It said 90 million people would, there's like 40 million people that are in poverty in this country, and they spend $90 million on launching a car for fun. Like, oh, the rich get, it's the way the rich are. It's like, no. Let me put this in perspective. People in this country, just in the United States, you know how much they spend on combining alcohol, tobacco together? How much that's spent yearly? $320 billion.
It's good for the economy.
$320 billion worth of alcohol.
That's more
and
than most. That's more than a lot of countries' GDP combined.
That would help a lot of impoverished people in this country. All right.
I think you need to make sure there's opportunities. More so than babysitting, but that's just me.
Oh, by the way, SpaceX employs about 7,000 people.
Yeah.
Here we got a note from our radio director. $81 million per person in the
Russians were charging.
Yep.
That's so this 90 million rocket, pretty cheap.
It's pretty cheap, yeah, and it'll be able to launch people eventually too. But then there's going to be a heavier version also.
Well, I thought you can build a giant trampoline and just take a run and jump.
There you go. The G-forces would be. I can't remember the other is this one heavier version or somebody else? No, this is their heaviest version, isn't it? Yeah, I think so. I was looking at I think the SLS system, Space Launch System, and they have two versions. One that will be able to lift about a little bit more than SpaceX, and one that will be able to lift about twice as much as that. So more stuff, a lot of space mission, rocketry.
Well, it's our future. We got to harness the solar system. We're gonna. The solar system's ours. And provided it's sterile, it's going to be really home for us.
Yeah.
Then we can just spread ourselves around. But if it's got little biologies running around in each little zone, we may have a problem.
Mm-hmm.
But I think she's all ours for future generations.
Yeah. Webb telescope is getting closer and closer. They just put the parts just arrived in California, so they're putting that thing. Been doing a lot of testing with the Webb telescope. That'll hopefully be going up reasonably soon.
It was supposed to go up this spring, Marty. Spring, but they wait till next October.
Is it
a year? Still another year and a half away.
More rocket testing again. Better to be safe. Expensive rocket. You really want a successful mission. So, testing.
I can't tell you how much of astronomy and the future of astronomy and the science of astronomy and the way astronomy is laid out in astrophysics is relying on this telescope getting up.
Mm-hmm.
It's ready to take on its role. It's the next generation of every science mission that's been going on for the last 10 years, 20 years. It's the evolution of these projects. Mm-hmm. It's going to take them deeper and finish completing some of the heritage stuff that we've started, unable to complete. It is so important. It's not the only one, But on the scale of importance, it could be as high as 60% of the field.
Mm-hmm.
Of course, if you're relying on it, it may be 100% of your field.
Yeah.
Especially if it's your PhD you're trying to finish.
Yeah. It's all about better and better equipment.
It's a beautiful, beautiful system.
Yeah.
America, thank you. The world's going to be great. The world's going to thank you for that one. I mean, you talk about the Chinese competing with you. Listen, I don't read Chinese. All right? Nothing serious. But I don't know the last time China's released information for me to read.
Mm-hmm.
I don't know what they're going to show me from their systems. I don't know if they're going to let me have access to their data from their collider experiments. Don't know. We'll see. But all I know is America says, here, John, take it. Just go tell the world about it.
Mm-hmm.
Have fun.
Yeah. I want to say hi to everybody that's in chat so far. We've got me, we've got Nick, Optronics, Glenn, we've got you, In the Quiet Wood, Red Shirt 3, Telemachus, and Salby in our chat room right now.
Now, this is Telemachus' first trip in. We want to say welcome. He's got a chance. He's had chances to listen to programs and repeat, and this is his first time having the opportunity to come in and say hi live.
Excellent. Glad to have you here. Oh, something I wanted to mention, I forgot about this last Wednesday to Optronics. There's going to be an eclipse of the sun on February the 15th, and it's only a partial eclipse, so you'll basically be able to see a notch taken out of the sun, but it's only visible from southern portion of South America and then down in Antarctica. So Optronics, check that one out. You might be able to actually see at least a partial solar eclipse come up on the 15th or so. So check on the details a little bit more for yourself. Make sure you're in the area. I'm pretty sure it's right in your area. You'll just be able to go outside and look, but I don't know what time of day it's actually going to be, if it's going to be near sunrise or sunset or anything like that, too. So might be some nice pictures from Antarctica, too. That'd be kind of fun. It's going to go pretty close to the South Pole, so that'll be fun.
Oh, Patagonia. I'd love to get down and visit that area.
I'd like to
unique
go.
Animals they had. Mm-hmm. They had beavers the size of Volkswagens.
Oh, wow.
Armadillos, like little buses.
Way back in
cars. Wow, just the animals that got to grow up down there. And then they got hit with a big asteroid, too.
I know.
Made a big mess down there.
No, that was later, wasn't it? Wasn't it?
Yeah, these animals here, the Patagonia ones, they're giants.
Yeah, but
they're after the dinosaurs.
Yeah, they were only like 3 million years ago, something like that.
There was when the land bridge made it between Panama and Panama closed. Mm-hmm. Then animals from the north came down, and southern animals came north. Like up here in the north, we got the porcupine. He's from down south. So we made it out okay. And some of our southern animals, like the bears, went down. A lot of them didn't transition, and a lot of them did. Mm-hmm. I find it unique that the porcupine belongs down there. He's part of that capybara families. Yeah. Those guys were big.
Yep. And what else, too? I've seen in some museums.
Darwin found the big fossils. He couldn't believe it. They're just huge.
Mm-hmm. Seen some in Florida museums where they had some pretty big animals down there. So they found some pretty big fossils and stuff like that. Opinion from Optronics that the Hubble should not be deorbited. I agree with that one. So if it'll actually stay up there and we get these bigger rockets going, it could be serviceable again. So I would be more in favor of having the Hubble telescope stay up there and still be usable. Would sound good to me.
Yes. Wow. I love checking out the Hubble every day.
Mm-hmm. It was a nice image from NASA the Hubble just took. I didn't recognize this galaxy. It is a big galaxy in Pegasus. I gotta look for my list of new general catalog.
Anything in particular they were looking at? Just a beautiful galaxy.
I think just a beautiful spiral galaxy. Yeah, it's NGC 7331. Let's see. astronomers on this image of how, as they're observing extraordinary exploding star supernova near the galaxy's core. Oh, when was this? 2014. Okay, so it was a while ago. So this could be one of those. It didn't say it's a heritage image, which means it was a while ago.
They returned to them, yeah, because if it's a couple of years old from the other one, there's parallax measurements.
Oh, yeah. And
light distance measurements, yeah.
And see if things have changed with that supernova, too. See if they see some expansion.
Alex Flippenyanko's been looking at a lot of supernovas lately with the Hubble. I think he got to look about 1,000 of them. Alex is a familiar name.
Mm-hmm.
And what he's looking at is the progenitors.
The original stars.
Yeah, they're sitting beside them, and whether or not they have companions. And he's using the Hubble to clean up a bit of a heritage project in its own.
Yeah.
It's previously surveyed these supernovas.
Mm-hmm.
And
go ahead.
No, so what he's doing, he's looking at them all again in a collection, and looking at the dusty areas around them. And these quirky little things, these supernovas, 1As, they can go twice. You can have a double supernova. They can go supernova, and then it can accrete. It'll have a core left, and it'll drag stuff off its companion, right? And once it gets to 1.4 solar masses, boom, it goes again, because electron degeneracy is still holding.
Mm-hmm.
So they've been getting these supernovas going off twice.
Yeah.
It'll blow off, leaving a core, and then it'll accrete the other star and blow off again.
Grab some more stuff.
That was pretty cool find.
Uh-huh. I've got a list for everybody. Let me put it in the chat room if you want to want to actually look at some supernovas. Here's a list. Let me put it in the chat room here. Oops, sorry. Hope that I hit the wrong button. Let's see if it'll come out. Yes, it will. Here we go. All right, this is the Rochester Astronomy Club. They have a page dedicated to supernova. They call them bright supernova. So everything that's like, 17 magnitude and brighter. 17 magnitude is really dim. I mean, that's photographic stuff. And right now there's nothing really, really bright. They've got one at 12.8. That is improved because they had another one that was like 13. That was the top one. So this must be a brand new one. 12.8 magnitude. So you can look on their website itself. They've got them in lists from the brightest down to the dimmest. From what I could see, there's like several dozen supernovas and novas every day, pretty much. I think most of them are novas. They don't get really, really bright, but they do. They post the novas too, so you can actually see a lot of these, especially if you have a telescope that will hook to a camera and take images of this stuff. So keep track of this page. So if a supernova, a bright one does go off, definitely will be on their webpage. I put that link into our chat room. It's one I check regularly. So I just noticed this one because I looked on Wednesday, and there was one that had been there for a little while at 13th magnitude, and this one that's at 12.8 just appeared. So fairly new one. Read down the rest of it, too. It's pretty interesting.
Well, that's cool.
Yeah. Sun has got a nice spot group on it.
I never got to check. I knew you were going to show the sun. I'm going to put the sun. I never checked. Yeah. That's okay. Marty got something.
Yeah. Now, Soho is the website is being worked on. They're updating their software on the website. So most of the information on the Soho website is down. You don't have most of the current images, or I don't see these solar winds and stuff like that on there. So they do have some images. But this is from Space Weather, taking the SDO image. It's a sunspot group designated 2699. It's actually flaring quite a bit. So those of you with hydrogen alpha filters and telescopes, you got to look at it for the next week, because it rotated on several days ago. It has not hit the center of the sun yet. Another 2 more days before it gets to the center of the sun, and then it'll be a week after that before it gets all the way to the far edge. So you've got a good week of looking at the sunspot group, and it's been flaring. It's had C-class flares, and now it's got B-class flares. So they're getting a little bit better. You got a good chance of seeing some solar flares. The group itself, well, the individual spots in the group are not real big. Maybe size of the Earth, maybe a touch bigger. The penumbra, the grayer area around the dark spots, definitely bigger than the Earth. The whole system, I'd say, is the size of a planet like Uranus, Neptune, something like that for the group. So it's a fairly good-sized group.
Yep.
Got some spots in it. Let me put that image into our chat room here, and everybody could check it out. And again, you can pick these links up on the home page tomorrow or something like that and check it out yourself. So check that out.
Guy Nick is picking them up.
Yep. So it's pretty nice sunspot group on the sun right now. Pretty rare. We're getting in the minimum. So if you don't see the sun this week, it might be months before you see another sunspot, and usually it's a really small one. So keep solar observers go for this one.
This last cycle must have been one of the ones you paid the most attention to of all the cycles.
Mm-hmm.
This is the cycle. I didn't know the sun before this last cycle. But listening to AFM, yourself, and others, and you get to pick up a lot.
Yeah. So we're heading.
It was really fantastic to learn about the cycles, and they talked about 2012 was in there, and it's the minimums that we've experienced before. It's been an exciting time for me this last solar cycle. I got to learn a lot about the sun, and a lot of great people explain a lot of great stuff.
Mm-hmm.
What's with all the great words? Leave it alone. I want to say thank you is what I'm trying to say.
All right.
Especially people like you, Marty. Thank you.
You're welcome, John. And thanks for being here tonight. Filling in when we need you. We used to be on regularly. Let's do a little station identification. You're listening to the Event Horizon here on Astronomy.FM radio. It is another Friday night. This one is February the 9th, 2018. About 9:30 in the evening for those of us here in the eastern portion of North America. Universal time, that would put it at 2:30 in the morning, Saturday morning, February the 10th, 2018. So that means we're right now for the next half hour. We're still live, and of course, it's a great time to come on over and get into the Astronomy.FM chat. Just go to the homepage. You'll see near the top where it says Radio Chat. Click on that. Just type in a name where it says name, and then hit the word login. Don't use a password or anything like that. There's no password needed. So it'll get you right into the chat, and you could ask questions of us if you want to, or other people in the chat room. Feel free to. Just come on in and look what other people are talking about. We'll put links about some things we're talking about in the chat, and other people will put things like their latest astronomy pictures in chat room too. So check it out, and of course, it's a really good time where the live presentation is when most people get into our chat room. But come on in anytime. It's open all the time. But you might have to wait a while for somebody else to come on in and be part of the conversation. Yep. Yeah. So glad to have you here. And I certainly invite people to come on in on off times too. Sometimes I look back and I'll see questions in there and go, oh, I wish I was, in the chat room and could answer that person's question. So I try to get previous questions and then answer them over the air, at least if I can catch them. All right, let's see. Oh, we got a space rock that flew by today.
Is that the one everybody was panicked about?
Yeah,
we only had 5 days notice.
Yeah, this was a fairly new one.
It come fast. The only notice I had out of it was like newspaper stuff, so they were like, oh boy, here we go. The end is nigh. This one was estimated to be, I'm going back on the prediction, not the actual observation, so estimated to be about 75 feet in diameter. Distance was reasonably close, though, at about 50,000 miles from the Earth. Yeah, that's pretty close. We have satellites orbiting the Earth at 25,000 miles away, so this came close, twice as far away as our geocentric satellites, well within the moon's orbit. Well, in fact, only about 2/10 of the distance to the moon is how far this object came by. And 75 feet, that would have been kind of a nice loud boom. Nothing more than maybe like, broken windows like Chelyabinsk. What's that, like 5 years ago now already? Wow. Time flies. Chelyabinsk a lot now, don't they?
Yeah. So something flew by close. Not even available or visible here in the U.S. It would have been on the other side of the world. So I think around Africa, India, something like that is where it would have been visible from. Let me put this article, even though it's kind of after the fact, but you can read about it. I'll put the article into our chat room here.
I like how NASA comes out and tells everybody, don't worry, though. Don't panic.
Yeah, that's right.
But, it's always good advice to keep your towel handy.
Yeah, that's right. They keep the...
Hitchhiker's Guide to the Galaxy, a little joke there.
They keep track of them pretty good, so we can see it well enough ahead of time, and then they can calculate in orbit and figure out how close
small,
it's going.
And that's why it wasn't seen until 5 days out.
Yeah, it's like about the size of a satellite, so not really very big. Kind of faint too. You would need. Now, they say a 8-inch telescope, and I really disagree with that. It was estimated between magnitude of 12 and 13, closer to 13th magnitude, about as bright as Pluto is. I have not been able to see Pluto in an 8-inch telescope. In fact, I couldn't see it in moderate skies in a 12-inch telescope, and it took up to about a 17-inch telescope before I was actually able to see it visually. So they say this thing is about that bright, 8-inch. Nah, I don't think so. So maybe did anybody see it? Listeners out there, let me know if you actually saw it. Let me know if you actually tried to see this rock fly by.
I hope you get a yes, and it was with an 8-inch telescope.
Yeah, that'd be nice. Yeah, well, it better be a truthful yes, though. So that was today for me. Here it was about 4 hours ago from our program broadcast time. So it would have been the middle of the daytime anyways, which means it was probably on the opposite side of the Earth because it was visible on the nighttime side. So not good for me. Europe, Africa was the prime area, I guess, to see that one. Kind of the equipment too, and the star charts and stuff like too. So they are possible. But one thing with a 13th magnitude rock like that flying by, when you get a big telescope, depending on what part of the sky it goes through, there's a lot of 13th magnitude stars out there. Our astronomy club's got a 22-inch telescope, and if you're looking for something that size, it's really, really faint, but there's a lot more faint stars than there are bright stars, so it's really hard to pick out. The only way you'd be able to pick it out is if you got in the area, you think you were dead on the area at the right time, and you're actually able to see something move. Depending on how far away it is from us, 50,000 miles away, yeah, you should be able to see that one move fairly easily. So that's the only way of seeing basically a Pluto bright star that's actually moving compared to the other stars in the background. Kind of tough to do.
Oh. You're welcome, Redshirt 3. I put a link in for Vista from Mars.
Vesta?
Vesta from Mars. Vista from Mars rovers looks back over the journey so far.
Oh, a Vista.
Vista, I know.
Gotcha.
I got it back.
I thought you were talking about Vesta, the asteroid.
No, they put what Curiosity's done. Okay. That nice panoramic. Has it ever there's a video in there, and it has taken a pretty good run. I didn't realize Gale Crater was a impact crater. I didn't know what I thought it was supposed to be, but Gale Crater is an impact crater.
Yep, with a bit of a mountain in it. Pretty old one, because they could tell that it's actually had water in it. So they have evidence of being basically filled with water, blowing winds, blowing dust.
And it finally cleared for this panoramic image to be taken.
Mm-hmm. Now, what I meant was that when it was filled with water, dust would blow across it. Dust would stick to the water, sink down to the ground, and then build up a layer of mud. And then more layers of mud, and that mud would start to compress on itself and start to compact. and it would get so compacted that it would actually form a type of stone. It's pretty easy to see, layered stone, kind of like shale, and can't remember what the other stuff's similar to shale. So then all the water's gone now because a few billion years later it's all evaporated away. But they can still see layered rocks in this crater, especially going up the mountain there. So more and more evidence that this is definitely filled with water in the past.
You can see the river where the river used to be in the vista. Mm-hmm. How it comes down out of the hills.
Okay. Some water flow.
Yeah, you can see the old dried up water flow.
Mm-hmm. Cool.
I don't know why. I knew it was Gale Crater. Gale Crater. Always heard that, Gale Crater.
Yep.
And for some reason, it was mentioned that it's an impact crater. And then it dawned on me. Gale Crater is an impact crater. Well, that's what happens when you put a mathematician out here to talk astronomy. But for some reason, I hadn't put those two together to make the proper thought. Gale Crater is from an impactor. Mm-hmm. I went, wow. So are they ever going to look for that impactor, or is that pretty well gone, you think?
I think it would be pretty much gone.
This thing is huge. I thought it was like a volcano or something. Or
it does have a big mountain in the middle of it. Mount Sharp, I think it's called. And
that'd be the spall that comes back up in the center.
Yeah. And that's got a lot of layered rocks in it, too. So part of that lake system that was in there. But
I hate to sound foolish, but I just didn't put two and two together. That was an impactor, like something came from outer space and hit Mars.
Mm-hmm. There's a lot of that on Mars. Most of the craters on Mars are impact craters. Yeah. Even though they've been filled with water in the past. There's another one, another picture of Mars. I think it was from the MRO, Mars Reconnaissance Orbiter. Let me put that crater in there. It's pretty cool. It's definitely got a river attached to it. And so the question is, was the water flowing into the crater, or was it flowing out of the crater? I'll put that into our chat room, and you can just see if you can figure it out before you actually read the text. And yeah, it is kind of hard to tell which way the water was going. So was it like from a mountain system, flowing into the crater and then, just basically wore a spot out? Or did the crater fill with water, overflow?
Oh, it looks like a tadpole.
It does look like a tadpole. Yes, it's nicknamed a tadpole crater. So the question is, which way did the water flow? I think they've got it figured out by more detailed observation, but I don't know if they do. Read the article and check it out. Let me give you what's up with moon and planets this week. Tonight, Mars is 4 degrees south of the moon. And Mars is also getting pretty close to Antares. It's about tomorrow. It's actually going to be 5 degrees north of Antares. So that's actually a really nice sight to see. So if you can get out and look for the planet Mars, which is early in the morning, a little harder for Northern Hemisphere observers. Southern Hemisphere has got it really nice because it gets up pretty high, but it's really low for Northern Hemisphere observers. So you'll see Mars close to the star Antares, and Antares means the rival of Mars, a very big red star. So they make a really nice pair. They're not always together like this, but I like it when they do get together. Just knowing the name of that star and the planet Mars right there. It's actually, I think that's really cool. Tonight also, Vesta, the asteroid, will be 0.9 degrees north of the moon. There's going to be an occultation. I think I looked this one up, and it's going to be an occultation visible from Antarctica. So not going to see that one too well for the most of the world. Sunday, we got Saturn 2 degrees south of the moon. So the moon is getting into crescent shape, getting closer to new moon, which would be next Thursday, by the way. And again, that's the 15th, and that's actually going to be an eclipse of the sun. So hopefully Optronics will be able to see that. Maybe get a picture of that, too. That'd be nice. Let's see, trying to think of what else is just generally up in the sky. Oh, I know what I was going to talk about. I forgot about this last week. Is the asteroid Ceres is back in the evening sky. So look for the constellation of Orion the Hunter. And then to the north of Orion the Hunter, constellation of the zodiac Gemini. Travel farther east into the very faint starred constellation called Cancer the Crab. And Ceres is kind of near but the northernmost star, Alpha Cancer the Crab. So a little bit east of that. So the asteroid Ceres, reasonably bright, fourth magnitude. That's what they're saying. Oh, that's definitely a fourth magnitude. Is easily visible naked eye. This is actually the brightest I remember it. Usually it's hovering around 6 magnitudes. So see if you can pick out Ceres, get a good star chart, and figure out where it's at right now. There are a lot of fourth magnitude stars in that area, so you might want to use a pair of binoculars in this region to pick it out. So you kind of have to learn some faint star patterns. You get the general constellation with just your eyes, then zoom in a little bit with a pair of binoculars, and then figure out the star patterns or which one doesn't belong there is Ceres, or if you have a star chart that actually, like a computerized star chart, like I use Stellarium, maybe screenshot it, print it up, and take it out in the field, and use binoculars to figure out which one's Ceres. And then if you have a telescope, I don't know if it'll actually show a round shape or not. I don't think so, even with a telescope. Just a little bit too small and too far away. But maybe a little bit.
Might get a hint of Yeah,
I might get a hint of it. And certainly every night you look at it, it'll be moving along. And don't forget, the space probe is still circling around it, and that would be the Dawn mission. Still sending back data.
Yeah, binos would be good. Red Shirt saying binos would be good. Binos are definitely an option in this part of the world, unless you really want to bundle up warm and go out. Binos are great. You can just go outside, take a quick look around, and jump back in the house.
I started out with binoculars, and I'd look around, and I said, oh, there's a fuzzy spot. I wonder what that is. And there's a fuzzy spot, and I wonder what that is. And I got a telescope, and I would point it back at those fuzzy spots. And sometimes they're pretty cool stuff. Sometimes it was a galaxy or a globular cluster. And sometimes it was just 4 or 5 stars that were really close together, and my binoculars couldn't, separate the stars. But it's a really good way of going just beyond the constellations to a little bit more detail, say for finding stuff like asteroids and comets.
I like that waning moon, man. That something about looking at that with binoculars. Like, it's spoiled. It gets hanging out. Yeah, it hangs outside my window nicely.
Yeah.
But the top part of the moon's so black. It puts it knocks the color, it knocks the brightness down just enough to make it really comfortable to look through with binoculars.
Yeah. Gets close to full moon, it gets too bright even binoculars. But I wear sunglasses. It actually works pretty good.
Sunglasses at night.
Well, did I say that last time here? Or was it before? It's like it's dark out. We're wearing sunglasses and whatever. What was that from? It's nighttime. We're wearing sunglasses.
Corey Hart. I wear my sunglasses.
That was the Blues Brothers.
Wow.
Yeah. Blues Brothers movie, wearing sunglasses at night. Yeah, I do that too, looking at the moon through a telescope.
Well, you got to cut down that light.
Definitely, yes.
They are too bright on your eyes.
Yeah, hurts your eyes and actually takes away your night vision. Yeah,
then you can't see well.
Yeah. Oh, let's see. Got a.
I've been dropping links in the chat room here for next week. I pick them up.
Nice. Got a launch coming up Sunday morning. We're not going to see this one from the U.S. here, though. But you can watch it on NASA TV. It's actually a Russian Progress cargo craft launching to the space station at our local time of 3:30 in the morning. That's Eastern Standard Time. And it's going to meet up with the space station in 3 hours after that at 6:30 in the morning. So if you want to see that launch, go to NASA TV. Just type in the word NASA, and you'll find it. Because get the homepage, just click on where it says NASA TV, and you'll be able to watch it. So, a lot of space missions going on late. I like that.
Yeah, I like that.
fun stuff. Juno. Mission to Jupiter just completed another close orbit of the planet Jupiter. Let me put that link into our chat room. This one was pretty close, too. This one was nice and close. Here we go. There you go, chat room. So, again, you can go to the NASA homepage and look at the Juno mission. Juno flew by at 2,100 miles above the clouds of Jupiter. That's really close. That is approximately the diameter of the moon itself. That's how close Juno got to the planet Jupiter. Just did that 2 days ago. And there'll be some images. There's a place where you can get the raw images if you want to process them and improve them. And you can do that yourself. You'll see some amateur astronomers actually will take those images and process them, change the contrast, the highlights, improve the detail. Sometimes change the colors, though, just to make it look a little more interesting. But you'll be able to start seeing those pictures come out real soon. Check out your favorite astronomical publication. I don't know how many more. It just completed its 10th orbit around Jupiter. I think it's
Cycle 24 it's called right now.
Cycle 24, is it?
The reason why I meant that, because I put the Hubble Space Telescope. I posted its proposal also. What they did is they worked with Juno. As Juno flew through the Aurora area, Hubble imaged it. This is the only opportunity Hubble would have, or any other telescope would have, to image both with Juno, using the instruments on Juno, and Hubble at the same time to image that auroral area. Because that auroral area, the auroral lights on Jupiter, they're common in other gas giants and other, exoplanets. Mm-hmm. And this gives them the opportunity to nail down more information on the magnetosphere itself and the auroral interaction. Because there's a really unique thing happening with these auroras. These auroras are so bright that you would be able to find the way they interact with their moons, the way Jupiter interacts with moons. There's enough light from the auroral and electromagnetic radiation interaction with its moons that you'd be able to tell that from exoplanet surveys. And the exoplanet surveys, it's a good chance you'd find the moon first before you'd find the star, before you'd find the planet.
Wow.
Just the way the moons interact with these auroras from these gas giants. And this is Hubble's first opportunity and only opportunity, it would have had.
No.
Or anybody would have had to image both with the two of them together.
So basically, the Juno stuff will be more detailed, but they'll be able to figure out what Hubble's actually looking at. So Hubble sees a little faint little blob on the top, and then Juno sees it in detail, and they say, okay, this is what we're looking at when we look at it from a long distance. And so, Juno's
interaction going through the magnetosphere itself. In the ultraviolet range is what they're measuring.
So if they see something like that on an exoplanet that looks exactly the same, but you're looking at it really with a long distance, then they'll get an idea of what it's probably really going on that exoplanet. Well, the probably
its moon, what the exoplanet. If the exoplanet actually has a moon.
Yep.
That is cool. That is cool. Find exoplanet moons. They haven't found exoplanet moons, but they did find exoplanets in other galaxies. Did we mention that one yet?
No, I didn't mention that one yet. Go ahead.
Here, I'll just post it in here. Doing microlensing using a quasar. So you have a galaxy. We're looking at a galaxy, and in behind that galaxy is a quasar. Now, that quasar is so bright, right? But we can use the galaxy in the front and the light from the quasar to macro lens. Now, it's going to bend the light of that quasar. And they know how the light of the quasar should act. The intervening galaxy has around 2,000 rogue planets in this one section that they measured.
Wow.
Because it interferes with the gravitational lensing of the quasar itself. There's a spectrum in the quasar that's showing, hey, I'm being interfered with. There's objects in front of me, and it's about 2,000 rogue planets. And these planets are about the size of the Moon to Jupiter's.
No.
But there'd be more rogue planets than that in a galaxy. This is just one little section they looked at, and the little section had roughly 2,000 rogue planets. Rogue planets not being associated with point light stars. See all the stars? They know where they're at.
Mm-hmm.
And so if there's any planets around those stars, it's already accounted for any change in lensing. But the rogueness of these other ones that aren't following any stars, they're just floating around, interferes enough with the light that they can take the mass estimate and put it at around 2,000 objects. Mm. And that was the first time they found exoplanets outside of our Milky Way. But you're never going to get a picture of them. It's just interfering with the spectrum, and the mass density would represent about 2,000 planets.
Wow. Cool. Getting a lot of data out of a little bit of light.
A tiny bit, but it's a micro lensing effect from a macro lensing technique.
Mm. Kind of back where we were like at the beginning, yeah, this is all about improving technology. It's giving us so much better science. And we'll continue to do that too.
Did I put in the one about Titan? They're sending
nope.
A submarine to Titan.
Go ahead. Are they really? Oh, they're trying to design a submarine for that'll handle something like Titan, if I recall. So put that one in there.
Washington State University. Sorry, okay. Washington State University is doing the designing, and they've already done the testing.
Mm-hmm.
I wanted to make sure Nick got a hold of that link.
Okay.
I did, yeah. So that was pretty cool. They got the camera system to work, and one of the unique things about Titan is the gas composition, the nitrogen, and the nitrogen can create bubbles, and so the submarines are going to have to put up with the bubbles they create in the methane lakes or the methane sea.
Uh-huh.
And if you get enough bubbles, it'll interfere with the ability to move a sub.
Oh, wow.
There's different densities that they've got to work through.
Mm-hmm.
So, yeah, it's quite interesting. It's a lot of better interesting read than I'm trying to scramble to get in the last 2 minutes.
We got a few minutes. Did you ever own one of those? 'Cause you're old enough to do this. Ever own one of those scuba divers, the little miniature scuba divers?
I know what you're talking about. You can see them on the back of comics and stuff, yeah.
Yeah, they were basically a guy who had a little bell-shaped weight in the bottom. It was only like a few inches tall, plastic scuba diver, and you would put something in there. I can't remember. I don't think it was baking soda. I think it was more like Alka-Seltzer. Pack it in there, then you drop it into water. The Alka-Seltzer would bubble up, create bubbles inside that little bell on the bottom of his foot, and it would make it rise it up. The bubbles would pop. You go back down, so go up and down for a couple of minutes. I think I owned one, but never got it to work. Now I'm old enough to do that. I got to find one again. That was fun.
Did you get the sea monkeys while you were at it?
No. Like you said, I remember seeing the ads for the sea monkeys, but never did it.
The dry shrimp.
Last article, we got a bunch more, but we'll do this one. New Horizons, the mission that went by Pluto, is now on its way to its next Kuiper Belt object. It actually imaged that and other Kuiper Belt objects. So basically, it's the farthest operating telescope away from the Earth right now. It's actually seeing quite a few things. The next object's like, right now it's like 4 billion miles out. So it's actually imaging things and sending back images of stuff in the Kuiper Belt. So that's pretty cool too. So we still got a little bit. I'm just dumping some astrophysics links here. Go ahead. We got
most detailed simulation. Mm-hmm. It's called the Illustrious simulation. It's computer simulation.
Okay.
It's been built about 3 times now.
Okay.
And the latest incarnation has been done, the next generation. And it shows you what the evolution of our universe itself would be.
Oh, cool.
Amazing. Really is. It's a lot of computer programming. Mm-hmm. It requires Germany's top supercomputer, one of the fastest mainframes.
Mm-hmm.
And hundreds of hours.
Cool.
So it's measuring about a 350 million light-year block of space.
Mm-hmm.
And, well, it matches pretty well what we see through our telescopes.
Cool. And that's going to bring us to the end of our program, everybody. Really appreciate everyone listening in. Don't forget, we'll repeat this program with more programming every 4 hours for the next 24 hours. You can always catch us on the repeat. I want to thank everybody that's been in the chat room tonight. Really appreciate you all being here. Time for us to say good night, everybody.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing.